So how many of you are the first time here at the conference? Okay, welcome. I think this is my 4th time here. This is actually a pretty cool conference. It's still a technical one. You don't see a lot of those. So that's why I like to come here. This session meant to be technical. Okay, good. It was impressive for me because it's the first session we do, and it's completely fully booked. So I appreciate everyone coming here. Should I start? Yeah. Do anyone have idea that I have now 45 minutes or 7 already gone? 7 already gone. Cool. All right. So welcome everyone. I don't waste the time with the. So my name is Jacint. I'm an SC for NetApp. I travel pretty much all my time. I work in Southeast Europe, which is Romania parts of it. I have a pretty packed agenda. I'm trying to give you some guidance between different technologies in disaster recovery space. And this is pretty a bad term because it's not really all the technologies here today are about the disaster recovery. I will share pretty much all my slides, so it's not necessary to take pictures. I will put down PPT, and I have 2 short demo videos in there. I need to figure out how I'm gonna share that, but I will. So we have 2 main technologies here at NetApp. So we talk about storage, right? So within storage technologies, we have 2 main technologies. One of them is standard replication. Standard replication is that you have one system on one side, one system on the other side. You have some sort of replication between them. And we have a MetroCluster technology. MetroCluster technology is a 12-year-old technology within NetApp. It is one of our best-selling products we ever had. It's designed by US people to US people. It was never successful in the United States, and the reason for that is that in the United States they're pretty much thinking in coast-to-coast replication, as that's just too far away from MetroCluster. MetroCluster is pretty damn successful in Germany and the Netherlands when you have proper infrastructure for that. Sorry for the Americans, they don't. In Europe, we do have real good infrastructure. So I'm gonna give you an overview on both of the technologies, and then so while the overview, you should already have an idea that which one to choose if you are in the consideration, and then I try to compare at the end which one is worth to take. Let's say like that. So obviously, if you have multiple type of configurations, they give you multiple type of benefits. So if you have a two-side setup, so more than one side, let's say like this, because we are not limited to 2 sides. So if you have more than one side, you have multiple type of technologies you can use to make your configuration in a way to be able to avoid disasters. So based on the technologies you can use, you can access lower or higher numbers. And the numbers here I called RTO and RPO. So who is not familiar with these 2 terms? Few hands. So RTO, so recovery time objective is recovery time objective is the time you need to recover your services after the disaster. RPO is the recovery point objective. That is the amount, let's say, the amount of data you are willing to lose. So let's say you have a disaster, and you say that, okay, if I lose 1 hour worth of data, I'm pretty okay with that. It depends on the data, and it depends on the company type. If you have, let's say, people generating data, probably 1 hour worth of data is okay to lose. If you have credit card transactions, probably you don't. There is one very important term here. So the architecture we work with is completely virtualized. So now we are talking about storage, and the way we are working with storage, we have physical controllers, and on top of the physical controllers, we are using virtual storage appliances. The reason we are working with virtual storage appliances is pretty much the same reason VMware figured out virtual services would be good, because if we are using everything virtualized, we have additional flexibility to apply. So think of anything like moving SVMs around, moving data around. You can use virtual storage appliances which are not tied to the physical storage appliances. And these storage virtual machines are basically virtual storage containers. So what they do, they have capacity, they have some networking, so it can be fiber channel or IP or whatever. They do speak storage protocol, so it can be fiber channel FCOE, it can be some sort of NAS like NFS or CIFS. And they have some capacity, and they are connected to physical or virtual servers. So they look like as a physical storage device, but they are completely virtual. So this is important to keep in mind, because I will use these terms in the presentation. So we have two things here. We have disaster avoidance, and we have disaster recovery. So these are two completely different terms. So disaster avoidance is something you try to figure out if a disaster is coming, and you try to be proactive and do something to make sure that the disaster will not hurt you. Disaster recovery is a reactive thing, so you let the disaster happen, and you have some sort of technology to fail over your configuration. So after the disaster, you can continue to run your operations. So these are the two terms here. So let's start with MetroCluster. So as I said, we have MetroCluster since 2003. We have MetroClusters in Romania as well, and we have MetroClusters in this area as well. MetroCluster is a nice technology. What it does is basically it extends the high availability of a storage system to multiple locations. So let's say you have more than one site. In a MetroCluster, it's typically two. So you have two sites in MetroCluster configuration, and you extend the high availability configuration of the MetroCluster from one site to two sites. In the past, it was pretty easy, so you simply took a storage configuration. It was an HA configuration, and you split the storage configuration in half, and you put one half on one side, the other half on the other side. It was good. People pretty much like it. We sold a couple of thousands and 10,000 worldwide, but people complain that we don't have local high availability with the MetroCluster configurations. So we have a new version came out last year, which is the data on top 8.3 MetroCluster configuration, and it has both local high availability and continuous availability between the locations. So basically what it does is that a standard cluster configuration, so you have a standard high availability configuration, it will give you high availability storage services in one data center, right? So this is pretty much everyone familiar with. You can lose pretty much everything from your storage configuration. You can lose controllers, you can lose networking stuff, you can lose drives, you can lose shelves, and your high availability configuration will make sure that your application can continue to run even if you have storage issues. So what MetroCluster does is that it will extend these value to multiple sites. Okay, so you can have you can lose completely a full site, and your MetroCluster configuration will fail over to the other side. The interesting thing with MetroCluster is it is not a DR solution. I'm sorry for you who are sitting behind this thing in the middle. I was pretty fond of this room at the beginning already. So MetroCluster configuration is not a DR configuration. It's a continuous availability solution. I will talk about this a little bit later, because it's very important to understand that that however MetroCluster is an awesome thing, I'm not sure you will need that. So it really needs to have the mindset of the continuous availability. So anytime you provision an application on a MetroCluster system, it's already mirrored to the other side. You don't need to do any additional step to make your application DR aware. So basically, anytime you create an application, anytime you create a NAS, or you create a SAN, a LAN, it's already replicated to the other side. So normally with DR, you say that, okay, set up application, set up replication, set up DR, test DR. In a MetroCluster situation, it's set up application, and it's already DR. So this is the design consideration. So how does this whole thing look like? So obviously, as with the new MetroCluster, the 8.3 MetroCluster, we have local high availability. So in the past, we had MetroCluster capabilities, but anything you lost on the primary side would recover failover to the secondary side. So with the 8.3, it's gone. We built local high availability. So local high availability, local high availability will give you the possibility to have high availability within each and every side. So if you have a controller failure, if you have chassis failures, multiple fan failures, pretty much things like that, the secondary controller will be able to take over the primary controller's load. Also with cluster 8 on top, we have things like non-destructive operations. So non-destructive operations mean you can, let's say, add additional adapters, you can upgrade your software, you can upgrade your firmware, you can upgrade your disk drive firmwares, you can upgrade your configuration from a previous generation to a new generation, and you can do all of these things online. So basically, with the local high availability, you get the infinite running storage system on side A. So you need the side failover only if your site really gone, or if you plan site maintenance, things like I'm going to switch down the power for the whole data center, or I'm trying my fire alarms, or things like that. There's a lot of flashing here. So site failover will be required if you have a real site disaster. So funny thing that the US, they typically make these pictures with tornadoes and hurricanes and things like what we don't have in Europe, but there are things we have in Europe, and if you plan for a disaster recovery, it's important to understand that the human failure is a lot more possible than having like a hurricane or tornado or even an earthquake. So basically, if your storage configuration or if your site completely goes down on one side, the storage system will be able to take over to the other side within 2 minutes. And that's a very important term. The reason we are shooting for 2 minutes, because that's roughly application can handle. So if you have a business critical application, let's say you have an Oracle database. If you take out the storage services from the Oracle database, you can keep the Oracle database running for 2 minutes without giving back the storage services for it. So keeping the 2 minutes in mind, we can do a complete site failover within 2 minutes. And the application will continue to run. So if you only lose the storage system will be able to do a site failure within 2 minutes, and the application will be able to continue to run. And that's a very important term. And also very important term from a management perspective, because if you have a management decision chain where it needs to take a decision for 50 minutes, then probably MetroCluster is an overkill for your solution. And it's very important that MetroCluster is completely transparent for the applications. I will describe how SAN works in MetroCluster, so you don't need any additional application plugin, you don't need scripting, you don't need storage plugins and storage drivers on the application side. It will simply work. Sounds too good to believe, right? So what do you need for a MetroCluster? So for a MetroCluster, you have some sort of network which is a cluster peering network. It's used by the two clusters to exchange information between them. The second thing you have is you have ISLs. So ISLs are typically dark fiber. So ISLs are dark fiber between the locations, or if you have multiple data centers in a single building, then usually you have direct fiber lines between them. They can be direct fiber, they can be DWDM, they can be CWDM. The distance limitation is 200 kilometers. There is a very good reason for 200 kilometers. The reason is the latency. So we can do a lot of magic on the software side, but we cannot override the physics terms. So 200 kilometers will mean that you need 4 milliseconds to send a packet from data center A and send it back to data center B. So that's 4 milliseconds. There's no magic to hide that 4 milliseconds at all, and if you still want to run your application running in a good response time, you don't need to extend it up to 200 kilometers. We take some exceptions. So if you have an extreme good infrastructure with extreme good DWDMs and things like that, we can check that configuration, and if the response times are good enough, then we will support the configuration. The reason we take this 200 kilometers very seriously, that this ISL is going to be your storage backend. So think of that, you write every single piece of data. Every single piece of data will travel on these 200 kilometers back and forth. So that's very important that you have a good infrastructure behind when you plan your MetroCluster infrastructure. And local HA will still handle all the local high availability requirements. And then on top of the local high availability, you have storage switch over and switch back. So let's start with a 1-2 minute demo. Let's see how this thing works. So let's look at the GUI, how it looked like. So I will log into cluster A. So this is site A. So when I log in, the first thing I'm going to check is in the configuration tab. I will open the configuration tab, because under the configuration tab I can check my peers. So I will check what kind of cluster I have on the other side, and I see that I can see the other pair of the MetroCluster is available. The other thing I'm going to show here, remember the storage virtual machines. So everything is based on storage virtual machines. So you are going to see that I have 2 storage virtual machines which are local, they are running, they are mirrored to the secondary side. And there are 2 storage virtual machines which are replicated from the secondary side to here. And pretty much the same you will see on the other side of the MetroCluster. So this is the side B, MetroCluster B. If you look at the configuration, you will see the peers that side A is a peer for side B. And we are going to see the storage virtual machines. The storage virtual machines provide the data services. And basically, I have the same configuration as on the other side. So I have 2 local storage virtual machines. One of them is doing block protocols. So one of them is doing fiber channel. The other is doing NFS. And you can see that there are 2 storage virtual machines which are replicated to here. So they are destinations, replication destinations. So they are sync destinations. And they are not running. So the very important thing is that I can do management of the local ones, But the remote ones which are replicated here, they have these small locks on the configuration. So you cannot see the configuration, you cannot touch the configuration, you cannot configure anything, they are read-on. Right. So let's see how the whole thing works from a fiber channel point of view. So what you see on the picture now is, I have two sides here. Side A, I have some sort of servers, they are connected to the fiber channel. I have the storage system on side A running my LAN. This is running my application. This is replicated to side B, so the other side of the MetroCluster has its replica of the LAN, and also have the logical interfaces. These are the interfaces. And I also have another server on the secondary side. So if I look at the connectivity in the basic setup, it's pretty easy. So if you look at these hosts which are on side A, this is directly connected to the switch, to the fiber channel switch. Probably in a high availability configuration, you have more than one fiber channel switches, so you have two of them. So basically, you are connected to the local fiber channel switches, and the local fiber channel switches has its pair on the other side, obviously. So you run a single fabric, so you have fabric ISLs between the locations. And basically, the fiber channel switch will be connected to the local storage, and it will be connected to the other storage as well. So your Oracle application, let's say running on your side A servers, your database is happy, your DBA is happy, and everything is good because my storage system is running. So basically, the server is connected to the switches, and the switches are connected to the storage. It's an easy thing. Let's say you take a storage failover. So you can see that in the previous picture, this was the primary storage, and now this is the primary. So what I did a storage failover. So remember, I said that the storage failover will take 2 minutes. So 2 minutes later, the configuration changed a little bit because my other storage, so the MetroCluster part, secondary part of the MetroCluster, the side B is running my configuration. So side B is running my configuration. That means that the LAN is presented on secondary side, side B, and the logical interfaces are active on the secondary side, side B. But very important to understand that the LAN is exactly the same as it was on side A. So it has the same size, it has the same serial number, it has the same capabilities. So if you look at the LAN at the Windows or a Linux physical or virtual machine, it's gonna be the exact same LAN. So there's no difference. The logical interfaces are also very important. That's why we are virtualizing the storage. Because when you create a storage virtual machine, the storage virtual machine will have the fiber channel addresses or the IP addresses. So this allows us, when we fail over from one side to the other, that we can keep the exact same fiber channel addresses. So think of that you completely fail over your configuration from one side to the other, and on the secondary side, the exact same LAN will come up with the exact same fiber channel address or the exact same IP address, so it's exactly the same run. So what's going to happen on the connectivity side, your server, which is still alive. So in this scenario, I only switched over the storage configuration. Your server is still alive, is still connected to the same fiber channel switch. So what it saw is your LAN gone away, and 2 minutes later, maximum 2 minutes later, the LAN comes back with the same LAN ID, the same LAN serial, and the same fiber channel address. So from the application point of view, my LAN gone, my LAN came back, and this is what we call all path down. This is a normal operation. In a proper configured application should be able to survive this scenario for 2 full minutes. About the 2 minutes. So the 2 minutes is designed because the 2 minutes is the limitation from the application. So when we design the maximums of the storage system configuration, we need to keep in mind to not have too many objects to keep the 2 minutes. So if you build a cluster configuration, you can have thousands of LANs, you can have thousands of storage virtual machines, you can have thousands of logical interfaces, but the more objects you have, the storage failover will take longer to fail over. So the demos usually I saw it was like 45 seconds. So site failovers in 45 seconds. And the reason for that was because they didn't build a lot of objects there. Usually they took 2 or 3 storage virtual machines per site, limited number of storage objects. And within the storage objects, you can build pretty much whatever you want. You can build your LANs, you can build your volumes. But you need to keep in mind that the more storage objects you have will make the storage failover longer. So I have another demo which shows that how the storage configuration look like after the failover. So after the failover, I log into my storage system. I don't have 2 sites anymore. I only have 1 site. So I only have 1 site. I'm going to check how the storage virtual machines look like. And now it's very, very interesting to see. That's cool. Is there any pause in here? So if you look at the storage virtual machines, it's still the same 4 storage virtual machine as it was. The important difference here is that now all of the 4 storage virtual machines run on the site which is surviving the disaster. So basically all the A site storage virtual machines and all the B site storage virtual machines are running on the exact same configuration. And now if I open any of the survived storage virtual machines, I can see that I can look into the storage objects, I can make configuration, I can do anything what I want. So the very important to understand here that I have the storage virtual machine. The storage virtual machine is running on the site where I configured it. It has its replica, it has its shadow on the other side, and once I have a storage failover, the storage virtual machine will come up, and from the application point of view, it's exactly the same storage system what I had on the previous site. So continuing the previous example, if I have a complete site failure, so it was not like a test, it was not like a planned event, it was not like a assigned maintenance, or it was not a DR testing scenario. I really have some fire, I really have some, okay, thank you. I really have some issue in my data center. So that means that my application gone. In this case, I will need to have some sort of application clustering so the application can fail over to the other side, because I can have my storage system fail over to the other side, but if there's no application to accept the data on the secondary side, I cannot do anything. So let's use VMware terms, because VMware terms are easy. So if you have a MetroCluster configuration, on top of the MetroCluster, you can run a stretch high availability MetroCluster configuration on the VMware side. So that means if you have a server failure, or if you have a complete site failure, you can use VMware HA, and your application and the virtual machine will restart on the other side, or even you can use VMware fault tolerance, so the application continuously can continue to run on the secondary side. And with vSphere 6, fault tolerance is not a joke anymore. You can have multiple vCPUs. You have a lot broader configuration what you used to have. So let's see SnapMirror. SnapMirror is pretty easy. SnapMirror is the NetApp way to do remote replication. There is one thing to keep in mind with SnapMirror in cluster data, we don't do synchron replication. With SnapMirror, we only do asynchron replication. And the reason is we are not doing asynchron, we are not doing synchron replication with SnapMirror, because we think that synchron replication is a joke. So synchron replication will lie to you, because you have the feeling, you have the impression that you have real zero RTO and RPO values, but it's not really true, because even if you can have zero RPO, the failover and the lot of manual work you need to do will take a lot of time to get back your applications up and running. So that's why for synchron applications and synchron requirements, we usually offer a MetroCluster configuration. So SnapMirror over the years has a lot of features. It has version flexible applications. So today you can have different on-top versions to replicate between. It has network compression. It supports the duplication. You can mirror clones. You can set up the replication that it will restart automatically if the network goes away. When it comes back, the replication will continue. You can have 255 to 1 fan-in. So you can have 255 systems replicating into one, or you can have one system replicating to 255 storage systems if you have 256 storage systems somewhere in Romania, let's say. We support IPv6, we support SNMP, we support SnapMirror with MetroCluster. So if you have a MetroCluster for continuous availability, you can also use a remote replication, which is pretty cool. And also, we understand how SnapMirror works, so we can, when we build a storage configuration for performance, we can also understand the replication capabilities, what the replication requires from a performance point of view. So let's look at the terms. So this is your cluster. In this example, you have a 4-node cluster. So this is called cluster, and you have nodes in it. The storage virtual machine is this virtual object. This spans from the first node to the last one. So it always spans for the full cluster. And the number one feature of the standard replication is that you can replicate actually data within your cluster. So if you have a 4-node cluster, you can have replication within your cluster. Obviously, the real use case of the remote replication is to replicate between different clusters of storage. So you have site A with one cluster, site B with another cluster, and you set up replication between them. The VMware term I can use here is VMware SRM, Site Recovery Manager. So basically, you can use VMware SRM, for example, to have automated failovers. So what SRM will do is will manage your replication from site A to site B. And basically, if you have your disaster, the SRM solution will make sure that your application is running. It is not magic in terms of time, so it will not give you a zero RTO solution, so it will not give you that, thank you. So it will not do the automation in 0 minutes. You still need a lot of time to start your applications on the failover time, but it at least automates. And also it gives you a lot of cool features, like you can test your DR scenario. The reason I took less time with the standard replication, because standard replication is pretty much understood by everyone. MetroCluster is a little bit more difficult. So what are the MetroCluster benefits? So MetroCluster is a continuous availability solution. So this is very important to understand. It is a benefit, but it's also in the same time it's not a benefit. So think of like, if you have a standard DR configuration, if all of a sudden you delete something accidentally on the primary side, in a MetroCluster configuration, it's already replicated to the secondary side, so you are in trouble, officially. We have a lot of technology within MetroCluster, so we can avoid that. So for example, if you delete a volume, it will be there for 12 hours in a hidden state, and we will only delete after that. And also you have the snapshots to recover them. But you can give you a lot of troubles if you do things like accidentally deleting volumes or logs. Because normally in a standard DR scenario, if you delete something on the primary side, you have some, let's say, 5 minutes or 10 minutes to figure out, oh, I just did something wrong. I still have the object on the secondary side, so I can fail over from that. MetroCluster is easy. It's super easy. So a MetroCluster, the technology of the MetroCluster will set up on the day when the storage system is set up, and then you can completely forget that you are running a multi-site configuration. So it will be automatic from any kind of operation. MetroCluster gives you a true zero RTO and RPO. So it will take zero time, and you don't need to have data what you're willing to lose. So it will, so once your data is written to the storage system, it's already written on the local and on the remote side. So once your application thinks that the data is written, it's written on both locations. And MetroCluster supports pretty much every single on-top feature. So you can have dedupe, you can have compression, you can have flash, you can have overflash, you can have everything. MetroCluster will work with every single configuration. If I look at SnapMirror, SnapMirror is a lot more granular. So MetroCluster is like, if you have a site failover in MetroCluster, you fail over everything. So there's not like, I fail over this application, because you fail over your storage system will take your all the application. It's like the commas in the roundabout, so it goes completely across, and it will take everything. So you fail over your storage, and all the application will go with it. If you have a replication-based solution, you can have replication based on volumes, you can have replication based on storage virtual machine, small little objects, not the full configuration. We have advanced features, so you can set up replication based on storage virtual machine. So we have a thing called storage virtual machine DR. So it will copy your storage virtual machine configuration, and it will also copy your storage virtual machine data, so your LANs, your volumes, and so on and so on. So when you have a storage failover, you can fail over the whole configuration with the IPs and pretty much all the application configuration. Yeah, I saw that, thank you. I got actually 37 minutes by the end. There's no real bandwidth limitations for a standard application. So as we work with compression and deduplication features, you can have pretty much everything. You can have extreme long distance replication. So one of our Romanian customers has their DR site in Vienna. So they are replicating from Bucharest to Vienna with SnapMirror. And it's really, really efficient, so you can use all the on-top features on this side as well. So considerations, RTO, RPO, what is the important? Can you generate 1 hour worth of data, which you did? So can you afford losing 50 minutes of data, 5 minutes of data? Or you cannot lose a single bit because, let's say, you're running credit card applications. That's an important thing. But the more important is the decision process. I had a customer, we were discussing about MetroCluster, and they was ready to invest a lot of money into MetroCluster once they figured out that actually it takes half an hour to make the decision that we have a disaster. So you have a monitoring process, you have the monitoring people escalates the manager escalates to the manager, the manager escalates to the VP makes the decision, but before the VP calls the real P, and then it takes half an hour to make the decision. I'm not sure you need to invest a lot of money to build a MetroCluster when it takes half an hour to make the decision that you can actually fail over your configuration. It doesn't make any sense. You need application clustering. So if your storage system fails over, if you don't have any clustering on the secondary side from the application point of view, you have the data switched over and you have an application to run the data. So that's very important. And you will need real infrastructure. So that's my last point. So if you need a MetroCluster, if you want to run a MetroCluster, if you want to build a MetroCluster, you will need dark fiber. So there's no other way around. There's no IP multiplexing kind of magic things out there. It really needs the bandwidth. It really needs the dark fiber, because this dark fiber is going to be your storage packet. So as I've eaten up all my time, I have any time for questions. So if you have any question, I encourage you to come to our booth. I'm there pretty much all day. I can answer any questions you may have. If you go there, fill out the form, you can have a prize. We have a few mugs, so as a lot of you came to this session, I'd like to thank you for you. Please fill out the forms. We have it on our booth. You can get something for it. I don't really know because I don't work for the marketing guys. Thank you very much.